Okay, this is lesson 4.2, operations with radicals. First, we want to review rational numbers, remembering that rational numbers can be expressed as fractions. So to add and subtract them, we must have a common denominator. So 2 to the third plus 4 to the fifth. I need a denominator that's common to 3 and 5. That's going to be 15. So I'll take 2 times 5 over 3 times 5 plus 4 times 3 over 5 times 3, and I'll have 10 over 15 plus 12 over 15, which will give me 22 over 15. Remember, we only add the denominator, the numerator, not the denominator. When we multiply rational expressions, we cannot multiply mixed numbers. Mixed numbers must be converted to an improper fraction before they can be multiplied or divided. So if I just have regular fractions, I multiply the numerators and the denominators. So 2 times 4 is 8, 3 times 5 is 15, and then I'll see if I can reduce. But if I have mixed numbers, I have to convert them first. So 3 times 2 plus 1. 3 times 2 is 6, plus 1 is 7, so that will be 7/3. 4 times 5 plus 1. 4 times 5 is 20, plus 1 is 21. So that's 21/5. 7 times 21 is 147. 3 times 5 is 15, so I'll have 147/15, and it is perfectly acceptable to leave this in improper format. Now, if you want to return it back to a mixed number, we need to divide 15 into 147. 15 goes into 150 10 times. This is just a little bit under 150, so I'm going to say 9. 9 times 5 is 45. Carry my 4. That'll give me 135, leaving me with 12. 15 does not go into 12, so this will be 9 and 12/15. 12 and 15 both divide by 3. Sorry, 4/5. So 9 and 4/5. Again, this answer is acceptable, or the reduced answer is acceptable as an improper fraction. Okay, when we add rational and irrational numbers, when we're working with irrational expressions, we are going to treat the radical the same way we treat variables. For example, if I have a 2 and a y together, I get 2 plus y or y plus 2. I can't combine them. They don't match. Well, if I add a radical and a non-radical, again, they can't combine. So for example, if I have 4 plus the square root of 5, I'm going to get 4 plus the square root of 5. I can't combine those. A rational number plus an irrational number will always equal an irrational number. If it has a non-perfect square in the term, it is irrational. So the same is true for subtraction. 6 minus the square root of 11, I just put them next to each other. 6 minus the square root of 11. I cannot combine them, and I'm going to get an irrational number. If I multiply them, just as we were doing with adding and subtracting, we treat the radical like a variable. So 5 times the square root of 3 gives me 5√3. So it's the same thing as if I was doing 5 times x would give me 5x. So we just set them next to each other. A rational times an irrational will give me an irrational. Always. 3 times the square root of 7 is 3√7. Irrational. Division works differently, and we're going to cover that later. So right now we've done adding, subtracting, and multiplying. If we are adding and multiplying two irrational numbers, so before we were doing one rational plus an irrational, now we're going to do two irrational. Now, it can result in either a rational or an irrational. It depends on what we have. For example, if I have an irrational number pi and I add it to the square root of 11, I can't combine those. So I have pi plus root 11 and it's irrational. If I have, that should have been plus. There should have been a plus in there. I'm so sorry. Here, I'll rewrite that. That should be 3 plus the square root of 5. If I have 3 plus the square root of 5, which is irrational, and I add to that a negative square root of 5, I get 3. What happened is these two root 5s canceled each other out, leaving me the 3, which is rational. When I multiply square root of 6 times the square root of 5, you multiply the terms underneath the radical to get the square root of 30. The square root of 30 is not a perfect square, therefore it is irrational. Whereas if I multiply root 2 times root 50, I get the square root of 100, which is 10, because it was a perfect square, and that makes it rational. So really, it depends on what we have as to whether or not we're going to get an irrational or a rational number. Now, to simplify radicals, we're going to determine if there are any perfect square factors under the term, and then we'll factor them out. There are two ways to complete this process. The first one will require perfect squares to be recognized. So here are our perfect squares. 1 squared 1, 2 squared 4, 3 squared 9, etc. And I've gone all the way up to 20 squared, which is 400. You may want to pause and take the time to write these down so that you'll have them to refer to. Or maybe, I don't know, do a print screen or something. Okay. When we reverse squaring, we take the square roots. So if we have perfect squares under the radical, we're just going backwards. The square root of 1 is 1. The square root of 4 is 2. That's because 2 squared equaled 4. The square root of 9 is 3, and that's because 3 squared equaled 9, etc. But simplifying radicals is not always as simple as taking the square root of a perfect square, because not every radical is a perfect square. So when we have non-perfect squares, we have two methods. One is factoring out the perfect squares and then simplifying, and the second one is to factor completely and then simplify. And they don't sound all that different, but they can be very different when you look at them. So first we're going to look at method 1, which is factoring out the perfect squares, and then we'll go back and look at method 2. So to simplify, the square root of 32 is 16 times 2. 16 is a perfect square. This is the same as the square root of 16 times the square root of 2. The square root of 16 is 4 times the square root of 2, and that gives me 4 root 2. Now you don't have to separate these like this. I can take this and go from here and know that the square root of 16 is 4 and just write 4 root 2. Here are some more examples. Okay, I have 50 and 72. Now 50 is 25 times 2. That's the square root of 25 times the square root of 2. The square root of 25 is 5. So I have 5 root 2. 72 is 36 times 2. And the square root of 36 is 6. And I left with a 2 underneath the radical. Now, in order to do this, you'd have to recognize that 72 is 36 times 2. And if you can recognize that perfect square, that's wonderful. But sometimes you don't know that 36 times 2 is 72 and that 36 is a perfect square. So that's when method 2 can really come in handy. Method 2 is to use prime factorization. So we're going to use all the same numbers so you can see that we get the same answer no matter which method we use. Now what we're going to do is we're going to make factor trees, and you can break this up however you want. 50 is 5 times 10, and 10 is 2 times 5. Now what will happen here, every time I have a pair of numbers that match inside under the radical, that's a perfect square. So what I'll do is, I kind of think of it like if you match, you get to pair up and go out on a date, and the two become one. So these two 5s will become 1 5 because I'm going to take the square root of it. And unfortunately, this 2, he didn't pair up with anybody, so he's kind of lonely and he has to stay home. So the square root of 50 is 5 root 2, which is the same answer that we got before. 32, I have 2 times 16, and 16 is 2 times 8, and 8 is 2 times 4, and 4 is 2 times 2. Now if I got 2 times 16 and I recognized 16 was a perfect square, I could have stopped there. But maybe I didn't recognize it, so I keep going. I have one pair of 2's. I have another pair of 2's, and then I have this 2 that's left over. So each of these pairs of 2's, one can come out. So this first 2 comes from this group, and then this second 2 will come from the second group, and then the leftover stays home. And for each pair, you bring out 1, and then you multiply them together. So I get 4 root 2. So as you see, we got the same answer. And then 72 divides by 2. And again, if I don't recognize that the 36 is a perfect square, I can keep going. And I have a pair of 2's and a pair of 3's and a 2 that gets left behind. So 1 2 comes out from this first pair of 2's, 1 3 comes out from this pair of 3's, and then that 2 got left behind, giving me 6 times the square root of 2. Prime factorization is really useful for big numbers that need to be simplified. Okay, so we don't want to let the large numbers intimidate us. If I see the square root of 5,276, I don't want to freak out and say, oh, I can't simplify that because that number is too big. We're going to use the rules of divisibility. So first I'm going to go over those rules with you. And I'm not going to go over all the rules. I'm going to go over the rules for the smaller numbers. So first of all, 2. Any number ending in 0, 2, 4, 6, or 8 will divide evenly by 2. All even numbers divide by 2. For 3, we're going to add the digits, and if the sum will divide by 3, then the number will divide by 3. For example, I want to know if 123 will divide by 3. 1 plus 2 plus 3 is 6. 6 divides by 3. So 123 will divide evenly by 3 as well, 41 times. So you can take the digits of the number, no matter how long it is, add them all together. And if that sum will divide by 3, then you know the whole thing will divide by 3. For 5, any number ending in 0 or 5 will divide by 5. For other prime numbers, such as 7, 11, and 13, we just want to try them and see if they'll divide evenly. There aren't any good rules for these numbers. And then finally, a hint. We want to simplify the square root and not give the approximate decimal answer, but you can take the calculator, take the square root of the non-perfect square. You're going to get a big long decimal, but whatever that number is, you only need to try whole numbers less than that number. So for example, if I'm taking the square root of 148, well, I know 144 is 12, the square root of 144. So 148 is going to be 12 point some stuff. So then when I'm checking the numbers to see if they'll divide into 148, I only need to check numbers less than 12 or less. So that's just a hint. So here we go, 1260. I'm going to factor this number and simplify the non-perfect square. So first of all, okay, I see that it ends in 0, so it'll divide by 5, or it'll divide by 2. Also, when I add these up, 1, 2, and 6 add up to 9. So this number will also divide by 3. So it's up to you what you want to divide by first. I'm actually going to divide by 10. And then 10 is 2 times 5, and that part's done. Now I have this 126. Now again, that's even, so I can divide by 2. So 2 goes into 12, so 63 times 2, and 63 is 7 times 9, and 9 is 3 times 3. So now what I'm going to do, just so I'm not confusing myself, the 10 was 2 times 5, so I took care of that. And 126 was 63 times 2, and 63 was 7 times 9, and 9 was 3 times 3. The numbers that are left over are the ones I need to see if I can pair off. Okay, so I have a pair of 2s. They don't have to be sitting next to each other. I could have a 2 here and down here. As long as I have 2 of them, they're a pair. I have a pair of 3s. I have a 7 that doesn't match anything, and I have a 5 that doesn't match anything. And I apologize if you can hear the noise outside. Apparently my neighbor is mowing their lawn. Okay, so the 2 and the 3 are paired off, so they come out. I have 1, 2, and 1, 3, because remember the pairs go out and become 1. And then the 7 and the 5 get left behind. Now I multiply those together, and so 1260 will simplify to 6 times the square root of 35. Now if you want to double check your work and make sure you did it correctly, square this number on the outside, so 6 squared is 36, multiply it by the number on the inside, and I get the same number again. That way I know I did it correctly. Let's try one more. 6912. Now I'm going to add all these together and just check to see if it divides by 3. So 6 plus 9 is 15, plus 1 is 16, plus 2 is 18. So this number does divide by 3. It will also divide by 2. I'm going to go ahead and divide by 3. 3 goes into 6 twice, 9 3 times, 1 0 times, and 12 4 times. So I have 2304, which will divide by 2. And 1152 will divide by 2. Oops, I said 2, I wrote 5. Don't know what I was doing there. Okay, so 2, and it goes into 11 5 times. With 1 left over, 15. It will go 7 times, and 12 6 times. Again, divisible by 2. 2 goes into 5 twice. 17 8 times, and 16 8 times, 144, and that's 2 times 72, which is 2 times 36, which is 2 times 18, which is 2 times 9, which is 3 times 3. So this one was a big long one, but again, we were able to do this. So again, I'm going to go ahead and cross out the numbers that I factored into other numbers so that I'm not looking at them. That's just kind of a... All right, I have 1, 2, 3, 4 pairs of 2s, and a pair of 3s, and then this one lonely 3 left over. So I have 1, 2, 3, 4 2s, 1 3, and a 3 left behind. So now I need to multiply all this together. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 3 is 48, root 3. There is my final simplified answer. And again, if I want to check that, I can square 48 and then multiply that by 3. Okay, now when we want to add and subtract radicals, again, we treat radicals the same way as we treat variables. We have to have a common radical, which is like a common term. And then we add or subtract the coefficient, just like we would on a variable. So remember, 5x plus 3x gave us 8x. It'll be the same thing with radicals. So if I have 4 times the square root of 5 plus 2 times the square root of 5, these parts match the square roots of 5. So I have 6 times the square root of 5. If I have 3 root 2 minus 8 root 2, as long as these match, I just take 3 minus 8. 3 minus 8 is negative 5 root 2. Now if I have multiple terms, I can rearrange them and put the ones that match together. So I have 7 root 3 plus 5 root 3 minus 3 root 6. Now this one doesn't match. So I'm going to add the 7 and the 5. And then I'm going to leave this minus 3 root 6 alone. It would be the same thing if I was saying 7x minus 3y plus 5x. I couldn't add the x's and the y's together. It's like putting oranges and apples in a basket. If I have 5 apples and 6 oranges and I put them in a basket together, I still have 5 apples and 6 oranges. I don't have 11 orbals. Okay. Now when we are faced with non-common radicals, we're going to simplify them to see if we can get them to match. So here I have an 8, a 32, and a 2. None of these match, so I need to simplify them and see if I can do anything to get them to match. So 32, remember, was 2 times 16, and 16 was 2 times 8, and 8 was 2 times 4, and 4 was 2 times 2, giving me 2 pairs and a leftover 2. So that was going to give me 4 root 2. Again, if you recognize that 16 was a perfect square, you could have stopped right here. Now 8 is 2 times 4, and 4 is a perfect square. Square root of 4 is 2, and I have a 2 left over. And then minus that radical 2. And see, now they all match. I can get them to go together. 4 plus 2 is 6. Minus 1, don't forget there's like an invisible 1 right there, gives me 5 root 2. Ooh, I wrote on where I was supposed to be going. Hold on, let me fix that. That's what happens when I don't look at this again before I start working on it. I thought I had put that problem down here, but instead I put it over here. Go figure. Okay, sorry about all the mistakes. We're going to do the square root of 125, 25, and 5, and I'm going to try to see if I can get them to match. So 125 is 5 times, see, 5 goes into 12 twice, and then it goes into 25 5 times, and that gives me 5 times 5, so I have 5 root 5, and then minus 25, that's just going to be a 5. And then minus radical 5. Now again, this one's not going to match, so I can't do anything with that one, but I have 5 radical 5 minus radical 5 minus 5. I just rearranged them. 5 minus 1 is 4, and this 5 that's left over just stays. Now when we multiply radicals, we treat them the same way as multiplying variable terms. We multiply the like portions together and then we simplify. So what I mean by that is we're going to multiply the 3 and the 6 together, and we're going to multiply the radical 5 and the radical 10 together. 3 times 6 and 5 times 10, giving me 18 radical 50. Now 50 can be simplified. That is 2 times 25, and 25 is a perfect square. So that means I can pull out that perfect square, and the 2 gets left behind, and now I have this 18 times 5. 5 times 8 is 40, carry minus 4, that gives me 90 root 2. Here is my final answer. Or if we have alike radicals, I'm going to multiply the 2 and the 4 and the 3's, and that gives me negative 2 times 4 and the square root of 3 times 3. Whenever I take the square root of a square, 3 times 3 is 3 squared. So I'm just going to write that down. The square root and the square cancel each other out, giving me negative 8 times 3, which gives me negative 24. So anytime you multiply a radical by itself, you're squaring it, and the radical will go away. And that's true for any number. So I could take 111 and 111. Since I'm basically squaring a square, The square roots go away and the number remains. Okay, now if I'm distributing, which is another form of multiplication, I'm going to multiply 8 times 2, and I'm going to multiply 8 times 3, because 8 and radical 5 aren't the same. I have to multiply by that 3. So I'm going to have 16 minus 24 radical 5. And I'm just going to leave it just like that because I cannot combine these. They don't match. Now if I have a radical, I'm multiplying 3 times 9 and 3 times 4. And this radical 5 will just hang out when I multiply by the 9, but then it will multiply by the radical 15. So 3 times 9, and then the radical 5 hangs out, plus 3 times 4, and then I have 5 times 15 underneath the radical. So 3 times 9 is 27, 3 times 4 is 12, and 5 times 15 is 75. Now 75 can be reduced. 75 is 3 times 25, which is a perfect square. So I have 5 times 12, which gives me 60 radical 3. And I cannot combine those because these two radicals don't match. And then sometimes I will have to FOIL. Remember FOIL? First, outside, inside, and last. So I'm going to do 2 radical 6 times 3 radical 2, which will give me 6 radical 12. And then outside, 2 radical 6 times 4 radical 8. 2 times 4 is 8. 6 times 8 is 48. Inside, so that's negative 3 times 3, which is negative 9. And 8 times 2, which is 16. And then last, negative 3 times 4 is negative 12. Square root of 8 times the square root of 8 is just 8. Now I'll need to simplify this. 12 is 3 times 4, and 4 is a perfect square, so I'm going to have 6 times 2. And 48 is 3 times 16. And 16 is a perfect square, which gives me a 4. And then 16 is a perfect square, which gives me a 4. And then 12 times 8 is 96. So this is 12 radical 3 plus 32 radical 3 minus 9 times 4, which is 36, minus 96. These terms match and these terms match, so I can simplify even further. Sorry, I'm running out of room. 12 plus 32 is 44. And negative 36 minus 96 is going to be negative 2. Carry my 132. And that will be my final answer. So sometimes there's a lot of steps involved, but as long as you take it step by step by step, be patient with it. None of it should be insurmountable. And that is working with radicals. Adding, subtracting, multiplying,